and I'm a PhD. And I'm a PhD student at the Department of Land Economy, and I'm also based here in the Cambridge Conservation Initiative. And so today's a hybrid session. We've got people in the audience here in the building and also people online joining. And we're hosting Professor Johan Rockström, who's the director of the Potsdam Institute for Climate Impact Research and professor in Earth System Science at the University of Potsdam. And we're very happy to have you here. At least your work on planetary boundaries was part of many of my textbooks, my studies, I'm sure, of most people in this room. And he will be presenting his seminar on the Do Global Commons Determine Our Future, which will be discussing humanity's future on Earth in the Anthropocene. We'll be evaluating the risk of triggering cascades in biophysical systems on Earth. As I said, we're very happy to have you here. Professor Rockström has published more than 150 pieces of work on global water resources, and he's published extensively the Planetary Boundaries framework. And as usually, today's seminars will be 40 minutes long, up to 40 minutes of presentation, and then will be followed by a Q&A session for 20 minutes. So if you have any questions in the meantime that you can think of during the presentation, either write them in the chat, or you can wait towards the end of the questions will be asked. Just 2 points of notice: after we finish with the seminar, there will be a social event outside in a common room. And so even those of you who are online, if you want to join the building and have them, ideally we'll have you here as well with us. Professor Rockström, but we're happy to have you online anyway. So without further ado, you may start the presentation. For those who are online, please remain muted while the seminar is going on. And if you have any questions, all of them will be addressed at the end. Thank you.
Yeah, thanks, Vasily, and great to be with you. And a pity that I won't be able to join you in the beer afterwards, but that will have to be another time. Let me share my screen here and kick this off. So wonderful to be with you. So what I will doing is to give you a kind of a state of affairs with regards to the integrated science of planetary boundaries and why we've come to this juncture where we now need to be governing all the global commons, the tipping elements that regulates the stability and resilience of the Earth system for our future as humanity on Earth. And we live in really turbulent times. So I'll be kind of walking through this from a climate perspective, from a planetary boundary perspective. But of course, our minds are today, in a way, integral to large parts of the challenge. Let me see. I'm trying to. Yeah, there we are. Sorry for that. Our minds are, of course, in the turbulence and the drama that we're facing in the doorsteps of Europe right now. And nobody's claiming that climate change is driving the war in Ukraine, but it certainly has ramifications with regards to the discussions right now on the oil embargo that the US is introducing, Germany being one of the countries really dependent on particularly gas imports from Russia, and how we're seeing a new security doctrine rapidly developing in this humanitarian disaster, which also has strong connections to the pathway towards independence from oil, coal, and natural gas in a world that has been for so many decades driven to insecurity by our over-reliance on fossil fuels. And what I will focus on now is, of course, how this insecurity and instability affecting humanity and stability on Earth is primarily focusing in on our planet. And the focus of the planet is particularly justified today because what's happening with regards to armed conflict is a similar type of global crisis as the pandemic that we are in the latter phase of, the pandemic, which is a zoonosis which in itself is a manifestation of the core of this talk today, which is that we have come to a juncture where we're now a force of change at the planetary scale. The zoonosis, the COVID-19 is a zoonosis. It's a viral spillover from wildlife to humans. with risks rising very significantly with our overexploitation, our unsustainable overexploitation of one of the planetary boundaries, namely biodiversity integrity, the stability of intact natural habitats. And we see a hockey stick of rising zoonotic viral disease outbreaks. Actually, all the pandemics in modern time are zoonoses. So we're seeing something really significant with the rising turbulence in the world, a turbulence which is interactions between human health and planetary health, and instabilities generated through health, environmental sustainability, security, and how we govern and manage the Earth system, having implications on also the social and economic development on Earth. So it is, of course, with some significant, let's say, recognition and alarm that we read the high-level results of the Working Group 2 report of the IPCC AR6 coming out last Monday, essentially the same day as the escalation of the war in the Ukraine, with the high-level message that the cumulative scientific evidence is unequivocal that climate change is now threatening human well-being and the health of the planet, and that any delay of concerted action will miss this brief window of safe landing zone to hold the 1.5 degrees Celsius mark. But it also emphasizes for the first time in a really convincing scientific way that we need nothing less than a planetary boundary framework to land safely on climate, stating clearly that safeguarding biodiversity and ecosystems are fundamental for climate resilient development, both in terms of keeping carbon stocks intact, meaning enabling a safe climate landing, but also to be able to cope with unstoppable and inevitable extreme events by having nature as a buffering zone, as a shock absorber to droughts, floods, disease patterns, pandemics that are bound to unfold if we're not able to kind of transition back into a safe space. And the statement that up to 50% of terrestrial ecosystems have to be safeguarded aligns exactly with the planetary boundary science that says clearly that on both land and biodiversity, we've transgressed the safe boundary, which means that currently, when we have transformed 50% of terrestrial ecosystems to agriculture, urban areas, and infrastructure, we've basically come to a point where we now need to have zero expansion of human-dominated landscapes into natural ecosystems. So the planetary boundary science kind of gets reconfirmation by the IPCC and aligns itself with the Edward O. Wilson notion of half Earth. But let's take ourselves back to climate. And of course, the entry point being that we are today at a point of exiting the Holocene temperature corridor. We are today at 1.2 degrees Celsius of global warming attributed to human emission of greenhouse gases, and it's the warmest temperature on Earth since we left the last ice age 12,000 years ago. In fact, we are on a path that we can scientifically define as nothing else than disaster. We are following, if we continue our current journey to at least the 2.7 degrees Celsius warming by the end of this century, a place we haven't been in for the past 4 to 5 million years. We exit the Glasgow COP26 with a potential, if all the pledges are implemented, to just hold the 2 degrees Celsius mark, but that would require all the nationally determined contributions to be implemented, the methane pledge, the deforestation pledge, and all the net zero targets, the 100 countries that have now pledged to reach net zero somewhere in the bracket between 2050 and 2070. If all of that is implemented, we can potentially reach just below 2 degrees. But that's what you see on the right-hand side of this graph. To the left-hand side, you see the latest assessment of scientific risk, which is not published yet. It's work that we are pursuing in something called the Earth Commission. I'll come back to that. It's the first attempt of gathering science in an interdisciplinary platform to provide science-based targets, planetary boundary updates for all the planetary boundaries beyond climate. And we are doing this by focusing in on the tipping elements, to avoid crossing tipping points for the large global commons or the biophysical systems that contribute to regulate the state of the Earth system. And what we find is that the risks of crossing tipping points, of irreversible changes of these tipping elements, is already at high risk when we go beyond 1.5 degrees Celsius. So as science advances, the temperature range for a safe operating space comes closer to the climate planetary boundary, which we proposed already in 2009 to be just below 1.5 degrees Celsius. And we have more and more science supporting that threshold. So you can see the drama here. We're heading towards a 2.7 future. We may potentially reach just below 2, and we have more and more science showing that already 1.5 is a risky threshold. But let's just go on back to where we are heading in terms of extreme events. The IPCC AR6 confirms not only that we have a higher degree of severity, of strength of extreme events, but they're also becoming more frequent. So we have a higher frequency of more severe extreme events. And in the midst of the Ukraine war, you may have read of the unprecedented floods in Queensland, in Australia, with just unmanageable levels of extreme floods, 14.5 meters of extreme flood events, when the 1 in 100 year flood maximum is up to 11-12 meters. So we're talking of massive human disaster with over 20 casualties so far. And this is happening in a world that is not bending the curve. In fact, we see the 2021 update showing that we continue rising emissions. And this is particularly dramatic when we have the AR6 and the AR5 analysis all showing that to be able to have a safe landing at 1.5, to operate within the remaining sliver of a global carbon budget, we have to bend the global curve of emissions no later than 2020. So we already are soon 2 years down the line. And today came the confirmation that 2021 is another record year of emissions from coal, oil, and natural gas. In fact, it's the highest emission level with a massive rebound after the pandemic, which means that all the calls for a sustainable recovery after COVID have basically come to naught. The 11 to 15 trillion of US dollars put in place as investments for a recovery from the pandemic, which so many scientists and civil society organizations called for an alignment with the mitigation pathways toward net zero, seems to have come to nothing. So just in line with the Don't Look Up film, we're still sitting tight and assessing, as Meryl Streep in her role as President of the United States put it, with regard to the shocking crisis emergency information from the asteroid rapidly rushing towards planet Earth. Now, IPCC gives us a remaining carbon budget of 400 gigatons of carbon dioxide to have a 67% chance of a safe landing. That is, 10 years of emissions. 2 years of this decade have already passed. So we're having, an urgency point, and science shows clearly that the only way to responsibly handle this very small remaining budget for an orderly phase out is to follow the carbon law. And the carbon law is an average median assessment from the over 100 IPCC runs that takes us to a 1.5 landing. And it shows that if we can cut emissions by half every decade, shown here in the gray curve, we follow a pathway of an orderly landing of roughly 7% reductions per year to a net zero world economy by 2050. But as you know, that will not be enough. We also need a food system transition from the largest net emitter, largest economic sector, net emitting 25%, up to 25% of emissions in the dark brown wedge, that needs to become the net largest sink of managed sector, namely the orange wedge here. So this is an agricultural revolution to also occur over the next 20 years. But that's not enough. We also need to start scaling in a dramatically significant way negative emission technologies, so carbon dioxide removal and carbon capture storage, shown here in orange. And not even that is enough. We also need to secure the carbon sinks in nature, in green on land and blue in the ocean, the over 50% emissions that are absorbed in intact nature. So it is, even the safe climate landing requires us to stay within the planetary boundaries on fresh water, land, biodiversity, nitrogen, phosphorus, and the oceans to have any chance of holding the 1.5 degrees Celsius mark. And the pathway is of extraordinary steepness. You may have captured this graph. It comes from The Economist, showing what the net zero pathways for the big economies in the world really entail. Look at China. China can be criticized scientifically for landing at zero too late. It is said we will peak no later than 2030 and then reach net zero no later than 2060. But, it is justified to criticize, but just look at the pace. It's extraordinary what China is pledging to do. Look at the US, a massive journey to zero. And as you know, India in Glasgow put forward its zero pledge. So just draw a line from the Indian point to zero by 2070, and you see we're in for not linear change, but transformative change. But nobody is yet delivering. The only region in the world that is starting to deliver is the European Union. And you can see that the European Union actually has kind of a realistic pathway to zero, given that the European Union is the only economic region in the world that has significantly reduced emissions over the past 15, 20 years. But let's go back to planet Earth and zoom in on the 1968 Christmas Eve Apollo 8 Earthrise. We have now the scientific evidence that we are at risk of destabilizing the entire Earth system. And this is why we scientifically have brought forward the planetary boundary framework, identifying the Earth system processes and systems that science shows evidence of contributes to regulate the state of the Earth system, which landed in 2009 in the 9 planetary boundary systems, scrutinized and assessed in the 2015 update, providing quantitative boundaries for a safe operating space, shown here in green, with the purpose of having a high chance of maintaining a Holocene-like planet, meaning a life support system that remains within the corridor of the biophysical range of the Holocene, the last 12,000 years of remarkably stable integration, which is the only period on planet Earth that we know can support civilizations as we know them. Because it isn't until we reach the Holocene, after having lived as hunters and gatherers and a few million people in really harsh conditions for some 200,000 to 300,000 years in deep ice age, we enter the last interglacial 20,000 years ago, and it's only then that we start domesticating animals and plants and enter the journey towards the modern world as we know it today. So the planetary boundaries are there to enable us to keep the planet in a livable state that can support civilizations, the modern world as we know it. 4 of 9 boundaries were assessed to be transgressed, shown here in our 2015 update. We're busy now working on the 3rd update to be submitted later this month, actually. And we saw there's a scramble of science updates right now, and one of them is on novel entities, the chemical pollutions boundary that we couldn't quantify so far. There's now an attempt of doing so, led in a paper by Lynn Persson and colleagues at Stockholm University, which concludes that we have transgressed the novel entities boundary. And I can share with you that we have a large group of international scientists looking at the water boundary, quantifying both the green and blue water boundary. And the green boundary, the conclusion so far is that we've transgressed that as well, that we're way outside of the Holocene natural variability range for soil moisture disturbances across all the terrestrial ecosystems on Earth. So we may actually very soon come out with a paper showing that we've transgressed at least 6 of the 9 boundaries, not only 4 of the 9 boundaries. So we have a significant task ahead. Just to give you the definition of the planetary boundaries, that this is not defining, let's say, a human equitable sharing of the environmental space on Earth. It is a biophysical safe operating space of having a high likelihood of keeping the Earth system within a Holocene interglacial equilibrium state, the only state we know can support humanity, and that to stay within planetary boundaries means keeping the large biophysical systems that have threshold behavior, multiple stable state, the tipping elements, on the right side of the fence. It's to keep them at a state where they continue functioning as shock absorbers, as cooling agents, as dampeners of disturbance, not to allow them to start going from negative feedbacks to positive feedbacks, self-reinforcing change, permafrost thawing, darker surfaces when ice melts and absorbs more heat, when rainforests shift over to a savanna state and releases carbon, when the large ocean systems lose capacity of dissolving carbon and instead have upwelling of carbon. These are the shifts we're trying to avoid with the planetary boundaries. That's why we focus in so much on tipping elements. And it's perhaps worth mentioning in the history of the planetary boundary science, which first came out in Nature, published in 2009, it came out just 1 year after this seminal paper by Tim Lenton and John Schellenhuber and colleagues, showing for the first time the global mapping of the tipping elements that regulates, as far as we knew in 2008, the state of the climate system. 1 year before this, you had the International Geosphere Biosphere Program, led by Will Steffen, producing its seminal volume suggesting that we enter the Anthropocene, given all the data on the hockey sticks behind the Great Acceleration. So you can see the trajectory here. Nobel Prize laureate Paul Crutzen proposes the Anthropocene in 2002. It's verified in 2007 by the IGBP and the Great Acceleration curves that are then documented, observations from all the environmental systems that we care about for human well-being. 1 year later, the tipping elements map is produced. And 1 year later, all these pieces of science are put together, and out comes the planetary boundary science. But 10 years after this publication, the 2008 tipping elements, an update is done. And this is what lands in the so-called hothouse Earth trajectory paper. Because what we see in 10 years of advancements of scholarly interrogation of these tipping elements is that they have different clusters of temperature thresholds. So you see in yellow the tipping elements where we have evidence of, let's say, the first victims at lowest temperature levels, lowest global mean temperature levels, and that this can lead to domino knock-on effects to more resilient tipping elements, but which would be at risk of sliding over thresholds because of the positive feedbacks caused by the first generations, and you get a domino effect. And we concluded in that paper, or rather put it as an hypothesis, that if we burn fossil fuels and cause climate forcing up to 2 degrees Celsius, that this could trigger Earth system feedbacks that could bump us up to 2.4 degrees Celsius, which could start a domino effect, that we could enter, not cross, let's say, fall over an escarpment, but that we would start sliding, as shown here in this kind of red journey, irreversibly towards a hothouse Earth state, meaning that we could potentially see a climate forcing of 2 degrees, but could lead a sliding towards a 3-4 degrees Celsius hothouse Earth future. This was put out as an hypothesis, and this work is now ongoing to see whether this is verified or disregarded. But as an input to this work, we also published the update on the 2008 tipping elements map, which we published just before the COVID-19 pandemic in 2019. And what you see here is the assessment of the state of the 15 tipping elements that were published in 2008. And our conclusion is that 9 of the 15, you see the 9 here, are showing signs of instability, showing signs of moving towards tipping points. And the most significant part of this work is that we have more evidence today of the cascade interconnectivity. And this is shown by the arrows. And you've certainly come across several of these cascade interactions. Just to share with you one of them that we are deeply exploring right now, which was published actually in something called the 10 New Insights in Climate Science, which we in this case is Future Earth, together with the Earth League and together with the World Climate Research Program, in a partnership produces every year as a contribution to the COP climate negotiations, a scanning of the 10 most important new advancements in climate science each year. We've done this now 4 years in a row, and we're heading towards COP27 with the 5th version. And one of those insights in the 2021 version was following exactly the work on these cascade interactions. So here's one cascade interaction published in a paper by Nico Wunderling, a colleague at the Potsdam Institute, which made it to this top 10 list of insights. The Greenland ice sheet rapidly releases cold fresh water into the North Atlantic through accelerated melting. This has shown proof of slowing down the AMOC, the Atlantic Meridional Overturning Circulation, the heat circulation in the North Atlantic. We understand this because it's the thermohaline engine that runs the whole overturning, and with more fresh water, the pump loses some of its thermohaline energy capacity. This slowdown has implications, of course, on weather patterns in the Northern Hemisphere, but also appears to push the monsoon system further south, which can explain a higher frequency of droughts and forest fires over the Amazon rainforest, which can explain the more rapid dieback in the Amazon. But not only that, it also locks more warm saline surface water in the Southern Ocean, which can explain the more rapid melting of the West Antarctic ice shelf. So this suggests a connectivity between the place on Earth that is changing most rapidly, the amplified warming in the Arctic, which then has connections all the way down to Antarctica. So this is one of the concerns we have. And in the Earth Commission, we're also working very actively on updating the tipping elements map from 2008. So here is unpublished data of the latest working version of this, the 20 tipping element systems as we understand them today. And what is significant here is that you basically can capture why we need the planetary boundaries, because there's not only the ice sheets and the energy systems of the overturning of heat or the El Nino system in the ocean, it's also the living biosphere systems. It is the temperate forest, the boreal forest, the soil carbon, the biological pump in the ocean, the Amazon rainforest. You see an integration of the Earth system captured in these tipping elements. But most importantly, we're trying to update the risk thresholds of crossing tipping points for these tipping elements. So you see on the x-axis here the list of the 15 now. We have 15 to 20 in the working list. The red embers diagram is kind of picking from the IPCC framework of identifying uncertainty range, and darker red gives a higher scientific certainty of risk of crossing a tipping point. And what you see here, so to the left, you see the thermometer is global mean temperature, deviation from the pre-industrial 0 point. And the business as usual line is the black line here, just showing that if we follow the current path, we are very likely, we're even outside the full range of uncertainty in science for several of the tipping elements. And just look at the Greenland ice sheet evidence we have today, but also have a look at what happens already at the Paris range, which is at 1.5. We cannot exclude crossing thresholds for both the Greenland ice sheet, the West Antarctic ice shelf, and very high significant risk for the low latitude coral reef systems. And this is actually verified by the first report of the AR6 that came out in August, showing that the risks for, sure, still low likelihood, but high impact outcomes cannot be ruled out, and that the AMOC has slowed down and we cannot exclude irreversible changes. So we're starting to see more and more broad scientific support for risks of crossing irreversible changes. And in the Working Group 2 report, which came out this Monday, we can also see a verification of exactly this conclusion, that already at 2 degrees Celsius or lower, we have this red embers, red hue of higher risk of crossing thresholds occurring. So if you look at the column furthest to the right, you are on the column of risk of causing irreversible changes. And as you see, the red hue of high risk is kind of climbing further downwards in temperature as our science advances. And just look at the ecosystem risks here with regards to, if you look at the second set of red embers to the right, the warm water corals have high degree of certainty, high confidence of crossing thresholds already within the 1 to 1.5 degrees Celsius bracket. So we are very much in an agreement across the scientific community that 1.5 is a real planetary boundary. Now, to add further reassurance of the need to take the safe operating space seriously, let me just share with you the first time a physically based mathematical climate model is able to reproduce the journey of our home, planet Earth, over the past entire quaternary period, the last 3 million years. So this runs by Matteo Willett and Andrzej Ganopolski with the Climber 2 model here at my institute, actually at Potsdam, which is able to reproduce in a remarkably accurate way, shown here in green, the oscillations between deep ice ages and interglacials for the past 3 million years. On the y-axis, you see again deviation from the pre-industrial global mean surface temperature. And the only thing I want you to recognize here is this remarkable finding that despite all the natural variability of solar orbital forcing and earthquakes and volcanic eruptions, we have never, as far as this analysis shows, ever reached 2 degrees. The warmest point on Earth has always stayed below 2 degrees, and the coldest point, deep ice age, has been in the order of -4 to -6. So the corridor of life on Earth is very narrow. It's been within a maximum range of +2 to roughly -4. And this is something that really gives a humble recognition of the precious state of the Earth system and how fragile the system is. But even more so, because the biggest insight of this is, why has the Earth system stayed within this narrow range? Well, it's not only because solar forcing has kept it physically within this range. Oh no, it's also about Earth resilience. It is about the living biosphere. It's the fact that, and here I'm quoting IPCC numbers, that 56% of the disturbance caused by our fossil fuel burning so far has been absorbed by intact nature on land and in the ocean. So you have this extraordinary, massive subsidy to the world economy, with the planet basically shoving large parts, over half of our climate debt, under the carpet by this ability of applying the biogeophysical processes, the planetary boundary processes of the Earth system, to remain in a glacial, in an interglacial Holocene state. So it's a proof of planetary health, but it's also a proof of the Earth system's capacity to remain and resist change within a certain range, a certain resilience attractor. And more so for the future, all the IPCC models that takes us safely to a 1.5 degrees Celsius landing assumes this capacity will continue. Assumes this capacity will continue. And that is incredibly important. The only reason why we are given by the IPCC a remaining carbon budget to have an orderly phase out of fossil fuels is that the models assume no surprises, assume no tipping points, assume that the ocean and land ecosystems will continue to deliver this massive subsidy to humanity by keeping us within the narrow quaternary corridor of life. Now, unfortunately, we see more and more papers like this that came out 2 days ago, showing that the resilience in some of the big carbon sinks are starting to dwindle. This is the resilience loss of the Brazilian part of the Amazon. We have the papers coming out a year ago showing that large parts of the Brazilian Amazon has already shifted over from sink to source. We published a paper a year ago showing that if we hadn't had intact nature, we would already have crashed through the 1.5 degrees Celsius point. Terrestrial ecosystems actually buffer, we estimate already today, 0.4 degrees Celsius. Intact nature only, not planted trees, not agricultural land, intact nature on land. The ocean provides another 0.4 degrees. So we have like almost 1 degree Celsius of Earth system dampening playing out already today to keep us in the corridor. And then we have papers coming out like this. We are very close to a tipping point on coral reef systems. We're very close to tipping points on West Antarctic ice shelf, and it has hysteresis, very difficult to come back. We have very likely crossed the tipping point already on Arctic summer ice, and IPCC confirms this. By 2040, we will have ice-free summers. And we have this base information from all the Argo buoys, the thousands of Argo buoys across the planet, showing that over 90% of the heat caused by our fossil fuel burning is absorbed in the ocean. Talk about Earth resilience, this capacity to absorb carbon dioxide and heat, buffering, hiding, trying to keep the system within its interglacial stable state. So this, of course, poses the question in my last 5-6 minutes, what's the pathway to the future? Can we achieve aspirational goals for humanity, the Sustainable Development Goals, for example, within a stable and resilient Earth system? What have we learned from the Limits to Growth 1972 that predicted this, that predicted that by the 2020s, we would start seeing a drawdown on the world economy because of the incapacity of the Earth system to continue buffer human disturbances, unsustainable disturbances. And of course, this is a very special year. 2020 in June, we'll have the Stockholm Plus 50 years after the Stockholm Conference, establishing the United Nations Environment Programme, 50 years after the Limits to Growth. We now have the Sustainable Development Goals. We have defined and charted our desired future. The Planetary Boundaries reshapes these 17 goals into what I call the wedding cake, which is that goals 6, 13, 14, 15, freshwater, biodiversity, ocean, and climate are planetary boundaries. They are the non-negotiable Sustainable Development Goals within which we can have aspirational social targets, within which we can have economic development, but we have to place them inside the safe operating space. So basically, the planetary boundary science means governing the global commons, the tipping elements, to keep them on the right side of the fence, so they help us not push us across thresholds. And this requires something we do not have, namely planetary stewardship. We need to collectively manage the global commons for our prosperity and equity on planet Earth. And this planetary stewardship agenda has a kind of a scaffolding, at least through the Sustainable Development Goals, but they require what Jeff Sachs and myself and some colleagues pointed out, transformations. We're no longer in this incremental journey. We need to have major exponential journeys across at least these 6 areas to have a chance of really delivering on the Sustainable Development Goals without undermining the state of the Earth system. So this means, as one kind of message to a group like yours, is that I think now, 40 years after the Brundtland Commission on our common future that defined sustainable development in 1987 and the run-up to the Rio Conference 1992, it's time to redefine sustainable development. Now it's about prosperity and equity, a good human future within a stable and resilient planet. We've come to that point. And Sir Partha Dasgupta confirms this. One of the most admired economists in the world, in the Dasgupta Economic Review of Biodiversity, concluded that the only way forward is to recognize all the biosphere systems as natural assets, quantify them and internalize all the externalities in the economy, and run the economy within strong sustainability regulatory means, meaning planetary boundaries. So basically placing the economy right at the center of science-based targets or planetary boundaries. And we're working on this. The Earth Commission, as I mentioned before, is an attempt to gather the scientific community to define a safe and just corridor for humanity's future on Earth. And it kind of boils down to placing our future within the planetary boundaries. Now, this is, of course, quite a dark lecture, and the question is the light in the tunnel? Well, I'll close with this slide, just to say that, at least in my career, despite all the turbulence in the world, I've never seen such momentum in the world where the whole narrative on sustainability is shifting towards being not a path to conserve nature or protect the environment, but rather a pathway for a more modern, more attractive, healthier, more secure, and more competitive future. And that mass movement, quite some significant progress after all. The European Union is leading the way to its through the Green Deal and the Fit for 55 and pathways towards decarbonization. Technologies increasingly, convincingly show that they are at grid parity on energy, so you can compete on solar and wind and hydrogen. Well, hydrogen is not really there yet, but you can still see a pathway towards investments, giving us a zero carbon exit point, which is not only a big cost, but rather a pathway towards a more attractive and more competitive outcome. Also, if you just judge it within conventional cost benefit or economic means. So there's something quite interesting happening, but we're right there on the edge, so to say. And the question is, will the ball tip irreversibly along positive social tipping points, or will we stay on this incremental path we've been in for such a long time? For better parts of the last 50 years, we've made progress. We have more than 500 multilateral environmental agreements, but it's all on incremental change. Now is the time to start getting the ball rolling in transformative change. Can we do it? Well, the window is still open, but scarcely open. And we just have another 8 years to really bend the curves. Can we do it? Yes. Will we do it? Big question mark. So with that, looking forward to the discussion, and thank you very much for your attention.
Thank you very much for your presentation. So to clarify for people who join a bit later, the way we're doing questions, for people in the room, you can just raise your hand and you just need to walk up to this microphone here so you can be heard. For people online, you can raise your hand and and then you can ask your question in person. If for some reason you cannot do that or prefer not to, you can always write your question in the chat and we can ask it on behalf of you. So yeah, you can start asking questions at any point. Are there any questions in the room that anyone would like to ask? Perfect. Yes, please. Would you like to come here and ask it in person? Yeah, here's perfect. Yeah.
Thank you. I really enjoyed that and I learned lots from it. I'm very interested in the Gaia hypothesis, partly because when I studied biological natural sciences, it was always dismissed or ignored for supposedly being unscientific. But the theories you present talk about planetary health, equilibrium, the Earth system and the integration of the Earth system, negative feedback. To me, there sounds like there are strong parallels between this kind of thinking about an Earth system being a benign, self-regulating, integrated system that is a safe operating space for humanity, and the ideas put forward by James Lovelock and others. I was just wondering if the Gaia hypothesis is engaged with at all in the kind of work that you and your colleagues do, and if not, why? Thank you.
Yeah, thanks. That's a great question, and I'm particularly grateful for the question because the simple answer is yes. That there is a strong connectivity and a strong alignment. Definitely, the planetary boundary science confirms the Gaia theory, and I am personally very inspired by James Lovelock, and many of the co-authors have close interactions, like Tim Lenton with James Lovelock, and what we're showing with the planetary boundary science is that the biogeophysical systems on Earth are all interconnected, and that the Earth system has this inbuilt biogeophysical resilience, this capacity to uphold negative feedbacks up to a certain point before shifting over to positive feedback. So that aligns with the Gaia theory. Then, of course, the Gaia theory has added some elements of almost some kind of self-determining feature of the Earth system, which kind of goes beyond the biophysical determinants, and the Planetary Boundaries does not suggest any such let's say more kind of human dimensions of the function of the Earth system. So in that sense, it may be, let's say, taking a step deeper into the natural science and the earth sciences. But I should say that among the Planetary Boundaries scholars, there's a very strong emphasis on seeing humans as an integral part of the Earth system, and not separating humans from the Earth system. I've always been of the view, despite being an interdisciplinary scientist myself, that the real added value of the Planetary Boundaries is that we do not, so to say, care so much about humans. We only care about the state of the planet for humanity, definitely, because that's the whole purpose of maintaining the Holocene state of the Earth system is for humans. The planet won't care if it's in an Eemian state or in a Holocene state. But still, the analysis is not to meet any human needs. It is to meet the requirements of Gaia, of the Earth system to remain in an interglacial Holocene state. So there's definitely a nice alignment.
Just to clarify, for anyone who wants to ask questions online, you can just click on the reactions button on the bottom right, and it will allow you to raise your hand. If you do, I'll notice you. Are there any other questions in the room that anyone would like to ask? Yes, please. You can, I forgot to mention before, but I can also introduce yourself with your name.
Oh, yeah, thanks. That was a great talk. My name's William. It's a question about the CO2 emissions, and fairly early on there was the figure that's showing that the EU has kind of reduced its CO2 emissions. Do you know the extent to which that comes about through actually just outsourcing those emissions to other places, like maybe quite heavily towards China? And then as China decarbonizes, might we see those emissions kind of come back to us in Europe, such that we actually have to manufacture the products that we are not doing so at the moment? So while it's sort of positive to see declines, is there maybe a chance that will kind of come back to us down the road as others decarbonize?
Yeah, no, that's a brilliant question, William, and also a good reminder that you're absolutely right. I mean, the European Union has reduced its emissions by some, if I remember right, don't quote me on this number, but something like 24-25%, perhaps 23 to 25% since 1990. It's the only region that has done that. What are those numbers? These are the numbers that are the officially reported numbers by the nation states. So you're absolutely right. These are emissions within the borders of the country. So it does not include the net let's say export minus import. So basically imported consumption, and the outsourcing of production to China is a very significant part of, therefore, unaccounted for numbers. How large is this? Well, it would be something in the magnitude of half of the reductions that the European Union has accomplished, because in countries like the UK and Sweden and Germany, we find quite a lot of calculations showing that on average the per capita emissions are in the order of 4 or 5 tons per capita per year, and you'd almost double that number if you factor in all the imported consumption. And not all of that comes from China, of course, but a significant portion does. So you're right. The reduction in Europe is a slightly misleading number. It just shows that that Europe is in fact decarbonizing its own societies, but because we haven't been able to change behavior to absolute levels of less consumption, we are still increasing emissions. Now, your second part of the question is, what happens if China then decarbonizes? Will that lead to a rebound to increase the emissions in Europe or elsewhere? Well, of course, the question is open. We don't have an answer to that question, but my answer to that question is very likely the answer is no, meaning that we can plug, so to say, put a stop on the rebound if big economies like China seriously start decarbonizing. So why is that? Well, because on the short term, you will definitely see rebound. In fact, we're right now in a very dangerous rebound situation that if Germany and like the UK stops import of gas from Russia, which I hope they will do, just following the embargo from the US, because we haven't plugged the pipelines to the east, there is a likely effect that Russia, Putin, simply sells the gas to Xi Jinping in China or to Modi in India. So of course, there is this leakage risk. But the reason why I'm more positive when it comes to China decarbonizing is the following. You have the three big economic regions in the world, the US, the European Union, and China. Now, all three have actually pledged clearly to decarbonize their economies in the order of 2050 to 2060. So these are the three big regions that have set in motion a path to decarbonize. The US and the European Union have shown that this journey can give big benefits, economic benefits. And we see it, for example, in the car industry, the truck industry, construction industry. We see efficiency gains and independence gains and competitive gains. So if China starts really scaling, which it has already started doing with its solar voltaics in particular, you can foresee spillover effects which rather are more likely to accelerate decarbonization in other economies than just shoving coal over to other markets. I mean, on the short term, it can happen because prices of coal will go down. The less we use coal, the cheaper it gets, which is a risk, of course, because the cheaper it gets, the more likely it is that some countries continue using it. But I think we will start seeing an unstoppable trajectory in the right direction. There is one caveat, though, which is that the best way of avoiding the risks you're highlighting is a price on carbon, because if we put at least 100 euros or 100 pounds of price tag on per ton of carbon dioxide, we can almost be sure of avoiding this rebound effect. But we don't have that across all markets. We have it now in the European Union, but we don't have it in all markets. So of course, I hope that we'll see regions like the European Union and the UK and the US being much more forceful in ensuring a price on carbon as a way of avoiding these leakage or spillover effects.
Thank you very much. We have one question from online. Vivek, would you like to ask it in person? Oh, perfect. Feel free to unmute yourself and ask your question.
Yeah. Thank you very much, Johan. And thank you very much for this inspiring insight about how different regions are contributing to reducing the carbon emission. Especially the EU story, which you mentioned, is inspiring. So my question is, you said about planetary stewardship. My research is focusing on local agroecosystem stewardship activities among humid, arid region of India in a state called Odisha. So if we see small landholding farmers, even single farmer is expected to implement more than 15 stewardship activities in their local landscape itself, local farming system itself. So at local scale, it demands huge individual action in stewardship activities as well as collective action in stewardship activities. even without any of the stewardship activities, the current pricing regime in agriculture system is not compensating the expenses being made by the smallholder farmers. So now we are going to add stewardship activities as management practices, which will increase the cost of cultivation. So how the economic system is going to accommodate the expenses for the stewardship activities? So what do you suggest for this? Thank you very much.
Yeah, thanks, Vivek. Well, to begin with, I think what you're doing is just a wonderful set of activities. We need those. I mean, that's where the excitement really starts, where you can set planetary boundaries, take them down to the regional level, take them down to the local level, and start seeing integrated, land, water, ecosystem management on the ground. In my mind, what you're putting your finger on, and that's why I was referring so enthusiastically to the Partha Dasgupta review, which you know so well, is that we have to price natural assets. We have to price the ecosystem functions and services provided by small-scale farmers. If you are a sustainable custodian of rich natural habitats or landscapes with high degree of integrity, both in biodiversity and carbon sinks and soil moisture feedback, so you keep rainfall intact, you should be compensated for that. You are providing humanity a commons, a service which should be priced, and that I think is one step. And of course, it's a big ask in a world that is unable to do so, even in the most advanced economies. But I think we need to really, let's say, fight for that. And one entry point, Vivek, I think, is the enthusiasm among the big multinational companies in the world for nature-based solutions. They are, as you know, they are scanning the market for investments, for robust in the sense that they have to be lasting, credible carbon storage investments, nature-based solutions that they can invest in. And I think that, if we can link the kind of activities that you're leading with companies' willingness to invest in nature-based solutions, then that can take us in the right direction. I had a discussion yesterday, for example, with Netflix. So I'm sitting on the advisory board for Netflix, and they are, they say the Science-Based Target Initiative for climate, which means aligning with science to decarbonize fossil fuel emissions by 2050, is not enough for them. They want to be carbon neutral today. But how can they be carbon neutral today if SBTi says that you should be at net zero 2040 or 2050? Well, they want to invest in, they want to decarbonize fossil fuel emissions according to SBTi, plus invest in nature-based solutions today. So, and they want to put the money behind that. So I think there is a matchmaking here that we have to accomplish in a much more efficient way. And we're not really there yet, but I see you have IPES on your logo behind you. And I think you're doing a great work to kind of push this science policy interface.
Yeah, thank you very much. So the need now is we should recognize people's contribution to nature.
Yes.
Yeah.
Yes.
Thank you.
Exactly.
Thank you for your question, Vivek. Thank you, Johan, for your response. Do you have time for one more question, perhaps, or is it? I know we reached our limit.
Let's take one more, but then I unfortunately need to jump into the next virtual room.
No problem, no problem. So, Alice, would you like to ask your question, please? If you can keep it brief. Thank you.
Yes, thank you very much for this presentation, Johan. It struck me that whatever is coming from all sorts of parts in terms of efforts to put us on the right path and bend the curve is, obviously having an incremental effect, and that's of change, and we need transformative change. And I am just wanting to ask you your view on how that shift could be brought about from a global governance perspective, given the complexity of encouraging political action that will drive the necessary legislative changes, for example, towards an economy that can operate within the safety, the safe boundaries of the Holocene. So, I mean, the past 50 years, that hasn't quite happened. However the problem has been framed, seems to have just led to an incremental progress. How would you frame that at a political level, or encourage that framing to come about so that we can have these shifts, at least from a sort of high level political global perspective, and within the time frame that we need?
Yeah, thanks, Alice. And yeah, in a way, it's a very good final question, because you're kind of asking, let's say, the Holy Grail for this whole transformation. How do we create the governance across all 195 countries in the world so that we can govern the global commons and keep ourselves within the planetary boundaries, not only in a safe way, but also in a just way, in a fair way? That's the quest. That's our charge. Now, let me just give you a few entry points to that, and also point you to a really interesting, let's say, network discussing exactly that question. But one entry point, in my mind, is that we have to change the narrative. We have to change the whole sustainability narrative, and it's happening as we speak. Moving away from the old narrative, which is really about, humans are culprits, we need to protect nature, it's about conservation, it's about reducing environmental impacts, so it's about a certain degree of sacrifice. While we know that can take us to a certain extent in the right direction. It has helped us actually with a lot of environmental legislations, but we don't get the big masses and we don't get the big movement, because what counts is human well-being and economic development. So I think the new narrative, which is emerging very rapidly, is sustainability as a pathway to success. Sustainability as the new step towards a new modernity. And we see so much evidence of that. It's not only rhetorics. I mean, we see it, in the electrification of mobility. We see it in the whole construction sector towards more wood-based, carbon sink, attractive, modern buildings. We see it in the health and the security and stability domains. So I think it's a question of changing the narrative and talking about this transformation in terms of particularly security, health, and economic development. I mean, if you want to be a successful nation in the future, or a really attractive city, or a really attractive employer, you better go sustainable, because that's the way to compete. It's the way to be more secure. It's the way to be more healthy. So that's number one. Number two, which we are exploring increasingly, is what we call keystone actors, but which in the mainstream is called clubs. So we never get 195 countries to sing the same song at the same time step and do exactly the same thing. But if we can get large enough minorities to join forces in alliances, in clubs, in what we call keystone actors, we've been mapping sector after sector. It's quite remarkable, actually, but not surprising. Look at the fisheries industry, the seafood industry in the world, thousands and thousands of companies. But if you identify it, it's no more than 10 big actors that dominate the global market. They fish all the oceans, they control all the value chains, they sit and lobby the most important decision-making seats. And it's the same in the food industry, and it's the same in the cement industry, and it's the same in the oil industry. They are just a handful of big actors. What you can, in ecology, we have this term keystone species. Well, these are like keystone actors in the global ecosystem. We try to engage with them. And if you can change the logic in the keystone actors, you can potentially, it's a hypothesis, change the logic in the whole world market. And in the same way with clubs, one of the excitements after Glasgow is this idea of establishing a climate club between the US, the European Union, China, and India. If you do that, you get 70% of global emissions. You need only 4 heads of state to agree. And if these 4 could agree on at least leveling a price on carbon and agree on a net zero pathway, which they essentially already have agreed on, it could tip over the logic across broader markets. I mean, it's just to say that, I think we've been doing the wrong thing in the past by saying the only way to advance environmental issues is to have full consensus all the time. We've based this on a kind of a consensus assumption. I think we've learned the hard way. Number one, let's just keep the denialists away from us. We don't care about them. They are always going to be there. They are a very insignificant minority. Number one. Number two, we cannot get the indifferent big majorities to just jump on board based on awareness and information. So the best is probably to find the alliances of change, the front runners, and bet on the fact that they will be so successful and that what they accomplish simply becomes the attractor. A bit like when Steve Jobs announced the iPhone and killed BlackBerry and Nokia overnight. It became the new attractor, and creating new attractors may be the way to push this faster. And then finally, just to say that I think we need to work with the UN, and I think we need to work with the United Nations Security Council, and I think we need to place sustainability as a security agenda item in the Security Council, and that's happening. Germany is working quite actively with work on connecting, migration, displacement, and conflict with climate security. So SIPRI, the Swedish International Peace Research Institute, is working very hard on an environment and peace report for the Stockholm Plus 50, showing that, if you want to have peace in the world, you better go sustainable. So sustainability being much more than only this really important environmental topic. So yeah, so basically just a flag that you see you're putting your finger on a whole new seminar.
Thank you very much for your question, Alice, and thank you for response, Johan. Sorry for everyone for running over, but it was an interesting question. Just one last thank you to Johan for your presentation, for your questions. Thank you very much.
Thanks a lot.
There's two very quick points of notice. We have a social event following right now, and secondly, the seminar in 2 weeks' time won't take place due to extenuating circumstances. They cannot attend the presenter, so just so you know, it won't happen in 2 weeks' time. But yeah, thank you again for your presentation, and have a good evening.
Yeah, thanks everyone. Great to be with you. Bye there.